start recording. So, algebra is about finding what? I think you asked, Joe. The unknown. Can't find this page? Just keep flipping. It will be there. It says Lesson 1, Introduction to Algebra at the top. Just keep flipping. It's right there. Probably found it. Okay. Algebra is about finding the unknown using symbols and mathematical operations. These symbols are variables. You can use all sorts of variables or symbols as variables. Letters in whatever alphabet you'd like to use. We typically try and keep it to the English alphabet or the Greek alphabet. And then whatever mathematical operations you know. The standard ones, addition, subtraction, multiplication, and division. But now any of your exponents and any of their corresponding roots. So squaring and square rooting, cubing and cube rooting, fourthing and fourth rooting are all now valid mathematical operations to solve these kinds of questions. So, simple example where we don't, in the day-to-day, we don't necessarily think about, okay, well, I'm going to make this thing X, then I'm going to solve for this. But you do algebra all the time. So, for example, someone named Jesnor comes to school with 10 candies to give her friends, and at the end of the day, she's only got 3 left. How many candies did she give away? Obviously, the answer is 7, someone just said. Who said 7, and how did you do it? Scarlett, was that you? Scarlett, how did you get 7? You just said 10 minus 3. You took the number she had, you took away the numbers she had left, and you were left with how many she had to have given away. Absolutely. What you don't necessarily realize is, without formalizing it, these are the techniques for algebra. The steps to algebra are not overly complicated. Abdal and Abdul, stop talking to each other, because you're going to ask me for help. And if you just talk the whole time, I don't want to help you, because I'm trying to teach you. And if you refuse to learn, why should I spend more time going back? So these are the steps. All we're trying to do is isolate the variable using opposite operations. To isolate the variable, that means we want to get the letter alone. Whatever it is, we want to get it alone. How? Well, we're going to look at opposite operations. That's all of this. We're going to undo whatever's happening to the variable to get it by itself. And we're going to start with some pretty simple ones today. Now, we've got opposite operations. If I am multiplying, what's the opposite operation for multiplication? How do I undo multiplication? Sorry? Yeah, division. Multiplication and division, these are opposites of each other. And addition and subtraction are opposites of each other as well. If I'm adding something by 2 and I want to undo that, I just have to take that 2 away, for example. So there is a way, a kind of a convoluted way we could solve this very simple question that Scarlett already told us the answer was 7. Now, I know what I'm about to do is more work than is necessary. But all I'm going to try and do today and over the next couple days is give you guys techniques that you can scale up when the problems get more difficult. The problem that I'm seeing in some of my other classes, one in particular, is that students will look at this and like, yes, I can do this. I don't need your stupid techniques. They've actually said that to me. I don't need your stupid math. I can do this in my head. Well, yeah, that's great. But as soon as I make the question even slightly more difficult, all of a sudden you can't do it in your head and you don't have the tools to deal with the harder stuff. So humor me. We're going to let something represent the unknown. Now, we're not going to use X. X is silly. Because what are we looking for here? What do we want to find? She came to school with 10 candies. At the end of the day, she had 3. How many candies did she give her friends? What are we looking for? How many? How many gave what? How many of what? How many candies? So we want to know how many candies. So what I'm going to do is I'm going to let my variable actually be somewhat connected to the thing that I'm looking for. You could use X for everything, but that's lame. Candies starts with the letter C, so why not let our variable represent the thing we're looking for? C is how many candies? Did she give away? Okay, so we're going to make our equation. How many candies did she start with? 10. What did she then do? Yeah, she gave a bunch away. Giving candies away is representative of what mathematical operation? It is subtraction. She gave away some candy. We don't know how much candy, so we're going to call it C. I mean, we do know. Scarlett already told us it's 7, and she's right. And we're told that after she gave away a bunch of candy, the amount that she had left over was 3. And so this is the thing we want to solve. We want to get C by itself here. So if I want to get C alone, what do I do? Yes, Zara. We want to move some things to the other side. Which one do you want to move to the other side? Okay, so we got a 10 here. It's currently positive, yes? Zara just said the 10 is positive. It does not matter what's happening here. It only matters what kind of number you have here. That number with no sign out front means this is a positive 10. To move it to the other side, I want to subtract 10 on both sides. Whatever I do to one, I have to do to the other to maintain this equality. We want to keep things fair in math. Whatever you do to one side, you got to do the other side. So 10 minus 10 is 0. And 0 minus C is just going to be negative C. This is gone, and I'm left with negative C. What is 3 minus 10? Negative 7. Cool. Now I have negative C equals negative 7. I don't want negative C. I just want C. C is the number of candies she wants to give away. Yes, Hassan Joe. You can. So let's do one of those two things. I don't care which one. They both will amount to the same thing. For the sake of what I'm going to do next, let's call it division. Because right now what you have here is, if I have a negative C, this is the same thing as negative 1C. I don't want negative 1C. I want 1C. And so I'm going to divide by what's being multiplied out front here. The opposite the opposite of multiplication is division. So I'm going to divide both sides by negative 1. Now, Hassan Joe, you're correct. We could have multiplied 2, but for the sake of keeping things real clear, I'm going to do it this way. Negative 1 divided by negative 1 is 1. So this is canceling, leaving me with just C. What's negative 7 divided by negative 1? A negative divided by a negative is a positive, and anything divided by 1 is itself. So C equals 7. Which is what Scarlett said 10 minutes ago. It just took a lot more time to get there. But again, this is all about showing you guys a set of techniques so that you can tackle anything, even the things that aren't as easy to do in your head. When you're ready, flip the page. I'm also, in the interest of fairness, I should also let you all know about one of the rules that I've now instituted in two of my other classes. I'm now instituting this to you guys as well. Anyone who would like to go work in ABED, Learning Support Services, or Crossroads, if you want to work in any of those classes after the lesson is done, you have to show me you've actually done the lesson that you were here for. Okay? So don't expect to leave if all your papers are still blank at the end of this, to whomever that may apply to. So here we go. I'm going to do a bunch of examples. I'm not going to do all 12. I'm going to do 10 of these just to make sure we're all on the same page. And then I'm going to do one on the subsequent page, and then we're done. Some of these are going to be straightforward and easy. Some of them will have a little trick. So let's do some one-step equations. One-step equations, the implication here is that these can all be solved using only a single mathematical operation. So I've got x plus 7 equals 11. The answer is obviously what? 4. Let's prove it. I want to get x by itself. So because I'm adding 7, I want to undo that. So what am I going to do to both sides? I'm going to take away 7. Here, positive 7 minus 7 is 0. 11 minus 7 is? And we're done. As easy as Josh made it look and sound. So next one. I've got x minus 4 equals 2. Now, I want to get x by itself. I'm currently taking 4 away from it. So what am I going to add? What is the opposite operation of subtraction by 4? We're going to add. We're going to add 4. And whatever you do to one side, you have to do to the other. Negative 4 plus 4 is 0. So we're left with x plus 0, which is x. And 2 plus 4 is? Cool. Let's check it, shall we? Here is how you check your work. Algebra is beautiful in that it has its own little built-in checking system. Once you think you have an answer, what we're going to do is we're going to take this answer and we're going to plug it back into the equation you got it from. So the original equation was x minus 4 equals 2. We're going to take the value we found and we're going to shove it back in there. If it holds true, that means we didn't make any mistakes along the way. So I'm taking my 6, I'm going to plug it where x is. 6 minus 4. Is 6 minus 4 equal to 2? You bet it is. So if that's correct, then this must also be correct. It's really easy to go back and check your work. Gentlemen. Yes. Here, Bilal is, yes, staring at Bilal is fun, but not necessary. Okay, next one. I have 6 plus x equals 4. What am I going to do? I want to get x by itself. So how do I isolate x in this question? I'm going to take away 6. Why am I taking away 6? Yes, Hassan Joe. Because the 6 is here and it's positive. It doesn't matter what's going on right here. This 6 is positive. To get rid of it, we're going to take 6 away. And whatever I do to one side, I have to do to the other. 6 minus 6 is 0, leaving me with 0 plus x, which is just x. And on the right-hand side, I'm going in order. If I'm taking 6 away from what was there, I need 4 minus 6. 4 minus 6 is negative 2. And now we can check it. Let's make sure we're right. The original question, here's my check. The original question was 6 plus x equals 4. And I'm going to take this value now and put it where x was. So is 6 plus negative 2 equal to 4? Well, 6 plus a negative 2 is the same thing as 6 minus 2. Is 6 minus 2 4? Yeah, so we're good. This is true, so we're good. Let's take a look at the next one. I've got negative 2 plus x equals 8. How am I going to get x by itself here? We're going to add 2. The mistake I often see here is students will say, look, I'm adding in between there, and so I'm going to take away 2. But I already have a negative 2. What's negative 2 take away 2? It's going to be negative 4. It doesn't matter what's happening here. It all depends on what this sign is. If this is negative, I need to add 2 so that these two then cancel each other out. And whatever I do to one side, I have to do to the other. Negative 2 plus 2 is 0, leaving me with just x. And on the right-hand side, I need to do my 8 plus 2. 8 plus 2 is 10. And now we can go back and check if we like. Is negative 2 plus 10 equal to 8? If I'm at negative 2 and I go up 10, yeah, we're good. Okay, some of you are itching for me to be done so you can practice it yourself. A couple more. I have 6x equals 24. What does 6x mean mathematically? It's 6 times x, you betcha. When there is no symbol written between, it's assumed to be multiplication. So then, if this is 6 times x equals 24, how do I get the x by itself here? If I'm multiplying by 6, I want to undo that. We're going to divide by 6, divide by 6. 6 over 6 is now 1, not 0. Hey, come on, why are you punching Toss and Joe? Oh, you weren't punching him? Okay. Okay. 24 over 6 is? Or 24 divided by 6 is? 4. Nice and easy. Let's keep going. Question 6, I've got negative 2x equals 8. What am I going to do? Yes. So I had some questions about this one in my C block earlier. If some students were like, this is negative 2x, so I'm going to add 2. How are the negative 2 and the x attached? If there's no symbol between, they're being multiplied. If I want to undo multiplication, I must divide. So we're going to divide by negative 2. And whatever I do to one side, I have to do to the other. Negative 2 divided by negative 2 is 1, leaving us with just x equals, and now 8 divided by 2 is 4, and a positive divided by a negative is a negative. Yes, you guys said negative 4, you're correct. Okay. Now, I got some fractions. A fraction is just a fun way to write what mathematical operator? A fraction is the same as division. It's always numerator divided by denominator. So now I've got x divided by 4. X divided by 4 equals 2 in this case. So to get x by itself, what do I have to do? How do I undo division? Yeah, the opposite of division is multiplying. So I'm going to multiply by 4. I'm going to multiply by 4. And now how I deal with this is we take what we've now multiplying and we divide it by what we were dividing by. 4 divided by 4 is 1, leaving us with just x equals, and now 2 times 4 is 8. We can check this again. I skipped a check on a few of these. Let's check it again. I had x over 4 equals 2. So let's take, if I have x over 4 equals 2, I'm going to take the value I just found, and I'm going to plug it in where x goes. So I've got 8 over 4. Is this equal to 2? Yes. That's true, so that must be correct. Almost done. Next question. I've got x divided by negative 6 now. How do I undo division by negative 6? What am I going to do? I'm going to multiply. You betcha, Josh. And whatever I do to one side, I have to do to the other. Here they're going to cancel. X is going to equal what? Negative 18. You are welcome to use a calculator to show some of the algebra. Okay, we're going to toss a star right here. Because the top did say one-step equations. These next two, I'm not going to do 11 and 12. We are going to do 9 and 10, though. These next two are not one-step operations. These are two. I'm going to define what we mean by isolating again. Isolating a variable means x, in this case, is alone and in the numerator. X is currently not in the numerator, so we have to get it up there first. So what I've written here is 5 divided by x equals 15. I don't want divided by x. I want x alone, and I want it up top. So to get x out of the bottom, what am I going to have to do? I'm going to have to multiply both sides by x. I want to undo the division by x. On this side, the x divided by the x is going to cancel, leaving me now with 5. You were down in the office. You are a gem, Mr. Keeley. After all that candy I gave you. Yeah, some days. It's true. Me too. So here we're left with 5. Here, 15 times x is just going to be 15x. Now I want to get x by itself. It doesn't matter if the variable's on the left or the right. We still want to isolate for it. Isolate means get it by itself and up top. It's up top now. Now we just have to get it alone. How am I going to get x by itself now? We're going to divide by 15. So 15 divided by 15 is 1, leaving me with just x on the right-hand side. What is 5 over 15? It is 1/3. As much as possible, I want you guys to leave things as fractions. Don't bring in decimals unless you absolutely have to. And you don't absolutely have to. 1/3 is 1/3. It is totally easy division. 5 over 15 is a fraction that you can reduce. Divide top and bottom by 5 gives us 1/3. Fantastic. This last one is the same. What's my first step here going to be? Multiply by x. Multiplying by x on both sides means on the left it cancels, leaving us with just -3. And on the right I have 21x. I want you guys to show your work the way I'm showing my work. Now to get x by itself, Abdal, what do? The question that we're all on together as a class. Same one you should be on. Yeah, so which one? Number 10. How do I get x by itself? I have 21 times x. I want to get x alone. So what do? What is the opposite operation of multiplying by 21? Help them out. Divide by 21. If you had to ask that question, you should really be paying attention. 21 divided by 21 is 1, leaving us with just x on the right-hand side. What is -3 over 21? It's going to be -1 over 7. I can divide top and bottom here by 3. And that is your final answer. Just for funsies, I want you to flip the page. And we're going to take a look at number 26. Just for funsies, one more example I want to do with you guys as a class before I give you your work. Find me question number 26. Here we go. This is similar to what we've done already. The only snag here is that I've tossed a coefficient on the y that is a fraction. We love fractions, right? I like that, appreciate that. So I have 4 over, the way this is written, this question says I have 4/5 or 4 over 5 times y. Now, this question can be done a couple different ways. You can do it in multiple steps, or you can actually do this as a single step. And I want to show you how that works. Right now, I've got 4 divided by, or 4/5 times y equals 10. I'm multiplying y by 4/5. So my one-step operation is going to be to divide both sides by that fraction. Because I'm multiplying by the 4/5, I'm going to divide by the 4/5. Here they're going to cancel, leaving me with y equals 10 divided by 4 over 5. Now that looks terrible, but we spent a whole bunch of the first chapter way back in September looking at how you divide by a fraction. How do I divide a whole number by a fraction? So we're going to take 10 or make it 10 over 1. Then what am I going to do? I'm going to change it from division to multiplication and flip the fraction. Instead of dividing by 4/5, I'm going to multiply by 5/4. And multiplying by fractions is easy. You just go across the top and you go across the bottom. It's going to be 50 over 4, which is, now we reduce, if it's possible to reduce. It is possible to reduce a little bit. 50 and 4 both divisible by 2. So this guy's going to become 25 over 2. You can leave it there, or you can ram that thing through your calculator and you're going to get 12.5. But what I wanted you to see is bring back this idea of dividing by a fraction and why it is we do that. This is why. Questions about anything I've just done? Okay, you have so much time. Here's what I'd like you to do. Flip back a page to this one. And your assigned questions are odds from 1 to 29. They're all one-steppers. In addition to that, I want you to do this page here too. I want you to tell me what the difference is between a yam and a TV announcer. This page is also for homework. You have so much time. You have 40 minutes. This is all we're doing today. On your mark, get set, giver. Yes, Matthias. Are you done all of those questions?
No, sir, but if I learn this on a different way, can I do it that way?
Which way?
So let's see here.
Which one am I looking at?
This one. You just switch the x and the 4 and do the opposite of the operation.
No, but you didn't. That should be 6 minus 4 equals 2.
Well, yeah, I'm not a but yeah.
Where's your answer here?
4.
No, but 6 plus 4 is 10.
Wait.
Yeah, I got that. Did you do the questions? The lesson?
Somewhere in here.
Somewhere in
I
here?
did do them.
As long as you did these perfect, yes, you may.
Thank you.
What's a big mistake right here? Where's the there?
There isn't one.
That's an info. That's no info.
It's true. That's why I didn't assign it.
I wasn't like listening to you.
No, you weren't. You bet.
Do you have an answer to them?
I do. I do. Let me find it. Okay. Let me do x equals 1, 9, equals 10, y equals 1. Oops. There you go, Sean. Okay. So.
Can I check all the numbers?
I don't have all. I mean, I could do them, but these are the. I've only ever assigned odds on that sheet, so I haven't actually done the even ones. Give me a sec. I can do them for you. Which we know isn't entirely. There are ways. People are tutors. Let's do this. I know you have to. Okay. I'm not writing on that. That is what needs to, I'll leave it to you to make that happen. Ireland's always open. Okay, Matthias, do you think you have a way to do it? I want you to know, I want no, it doesn't have to be any relationship. Yeah, no, because all you're doing is all you're consistent with how this happens. It depends what else is up here. If you do a long structure here, you need to make sure this whole thing goes down. Yeah. So as long as you're careful how you apply it, yeah, it should always work. Yes. No, that's not good. So you're dividing by 6, right? You change it, you said negative 6 divided by negative 4. You want to divide both sides by negative 6. Negative 4 over. Negative 4 divided by 12. Write this out. Move the variable that is in down here. Because you're multiplying here, if you want to move the variables over, you have to divide it out. Which you don't want to do that. You want to leave the letter here. Because this is multiplying, divide by negative 6. Divide by negative 6. Now you have negative 4. Here we go. Your fractions are numbers too. You're allowed that fractional aspect. Emerson. You're currently divided by 4 and the thing's negative. So we want to make it positive and we want to get the opposite divided by 4. What's the opposite of divided by negative 4? By negative 4. Negative 4, no? Do that again. 20. If you guys are done and want an answer key, I have one. Just for the odds, if you also did the even, I don't have the answers to use yet.